welcome. In this tutorial video, I will talk about how you can create and customize scatter and line plots in KIWI Explorer. This is the first in a series of 3 videos on the topic, and in this particular video I will cover the use of basic settings, such as the selection of the variables shown on the plot, the selection of the style of plot. I will also talk about how you can control the component of the axis, and how you can show reference lines on top of the data. Before I switch to the application, I would like to mention that the features of data subset and data stratification, which are mostly consistent across all the EDA types available in KIWI Explorer, those features have been described in separate tutorials and will not be covered specifically in this series of videos on scatter and line plots. Moving on to the application now, I have opened KIWI Explorer for a single data file called subset_demo.csv. This is a fairly typical population PK dataset. This page is shown side by side with the profile manager, which I will use to illustrate the settings that you need to define to achieve a particular design. Before you start defining the graphical settings of your scatter and line plot, you must first think about the subset of the data that you want to use to create this plot. The default behavior of KIWI Explorer is to use all the records of the dataset. And in a typical pharmacometric analysis dataset or a non-MEM analysis dataset, you could have records that are associated with different things, like your dosing records, your observation records. If you're talking about a PK/PD dataset, you often have different types of endpoints. You can also have those dummy records that you can use to trick non-MEM into behaving a certain ways. So you really have to think about which records you need to use for your plot. And in our particular case, I will use a series of records that are defined by the use associated with study equal 1, dose equal 10, and samp equal 1. So study and dose are fairly self-explanatory. Samp is a variable that we use for designating dosing versus sample records. When it's 1, it's a sample record. So I'm subsetting to the sample records collected in study 1 and dose 10. And I'm going to use all the records within this subset. So with that in mind, let's go now to the first profile, which illustrates the default behavior of the scatterplot profile. The default style is a scatterplot showing the y-axis, a default y-axis, which is the dv variable, versus a default x-axis variable, which could be TSFD, TSFE, or time. The basic settings panel is the panel that controls both the design of the plot. This is the second field. The x and the y-axis variables are controlled by the third and the fourth. So if you want to select a particular x-axis variable and a specific y-axis variable, you can do that. Here I'm using a log version of the observation versus a time variable, which is the actual time since first dose. I'm going to open the basic settings for the second profile. I'm gonna accept the rerun. So here you can see that I've selected my ATSFD, or there's a typo here, ATSFD for the x-axis, and the y-axis variable is logdv. Both fields are dropped down, and they list all the variables that are available in your dataset. We will see in the next tutorial that the y-axis variable is actually a multi-selectable drop-down, so you can select multiple variables here. In this case, I only selected one, logdv. You can see here that the x-axis title was set to the name of the variable, while the y-axis title was set to the label of logdv. And the reason is that logdv has a default label in the library of variable and units, but the ATSFD is not here. So if I scroll down, logdv has this default label that has been used here. In the next profile, I'm going to illustrate the selection of a different different plot style, and I'm going to use the line plot design. I'm actually illustrating here a pitfall that you must try to avoid. When you select a line type or a line and a scatter and line type, KIWI Explorer will connect the data in the order it is provided in the dataset. So in this case, we had 6 to 8 subjects, and the line is actually starting for one subject, going through the entire profile of the subject, and then connecting the end of the data of the first subject to the beginning of the data from the second subject, and so on. So you have these artifacts line that are showing up here. This is because, again, we're using all the records in the data. When you have, just showing the basic settings for the line plot profile. Yes, doesn't matter. The plot types was selected to line plot, and I kept my two variables the same as in the second profile. If I switch to the next profile, you can see that there is a little difference between this plot and the previous one. You don't see those artifacts. So the reason is that in this particular profile, I have not subsetted to the samples. I kept all the records from study 1 and dose 10, including the dosing records. So that data set was, at least for study 1, was a single dose data, and the value of the objective function, the value of the dependent variable on dosing record was set to missing. When KIWI Explorer reads the data and find a missing value for DV, this will break the line. So because the dose records were at the beginning of each individual profile, you end up with actually what appears to be 8 lines or 6 lines. This is actually a single line, but that doesn't connect between, or that try to connect to missing information but cannot, and therefore start again. If you had missing concentration in the middle of the profile, the the profile of a single subject would be shown, for example, here, and would stop if this data point was missing, and it would start again here. So missing data or missing value of the y-axis variable will result in broken lines. So that's one way to achieve the traditional spaghetti plot design. A much safer way to do that is illustrated in the next profile, which is also something that was illustrated in the tutorial on data stratification. So to use the best way or the best design to create a line plot or a spaghetti plot is to really subset to your actual sample records, but also to use stratification and stratify by the subject identifier variable in the grouping variable. So you will create different groups for each value of the ID variable, and then you need to set the last field of the stratification panel to false, which refer to the use of different symbols by a level of the grouping variable. So you're telling KIWI to distinguish each subject and consider those different subjects as different groups of data, but to use the same design, the same black line for all of those subjects. That's the best way. You don't have to assume that a missing data will start or break your line at the beginning of each subject dataset or data subset. Moving on to the next profile, which is essentially the same thing but with the symbol in addition to the line, and this is just achieved by selecting the scatter plus line plot option in the plot type field. So this is the last type of plot that you can select from the scatter plot profile. The next profile will illustrate the use of custom axis title. So here I am displaying a concentration with some kind of log scale unit, and the axis title for the x-axis is actual time since first dose in hour. The way you can control the axis titles is to go to these x-axis and y-axis panels. I'm going to show them, yes, top of each other. They look exactly similar. One is for the x-axis, the other one is for the y-axis. They provide the exact same settings, and I did not choose the right profile. So that's my x-axis, in which I have enter my custom text in the x-axis label field, and I did the same in the y-axis label field. So this label will supersede any labels that would be defined in the variable labels and units. In the next profile, I will use the custom axis range to zoom in on the first 12 hours of the profiles. This is also something that you can control through the x-axis or y-axis panel. And here I provided an axis limit minimum and maximum, went from -1 to 13. There are two things I want to mention about axis range. first off, the values that you enter are really the value that control the limit of the plot, the real border of the plot. KIWI Explorer will not add a little bit of margin to the left or the right of the intervals that you define here. It will strictly apply these values. So you need to think a little bit ahead in terms of I want to show the 0 to 12 hour, so I'm going to put a little bit of margin below my minimum, and I'm going to add the same margin above my my maximum value. So in this case I put an hour before and an hour after. The second thing is that you need to provide the two values, both the minimum and the maximum. If you only provide one of these values, it will simply be ignored. The next profile is illustrating another thing that you can control on the axis, which is the application of a transformation function. In this particular profile, I kept using this log dv y-axis variable, so the concentration on the log scale, but I have applied a transformation function in the y-axis panel. I have applied this exp function, which is an exponent function in R. You need to use a function that is a recognized or valid R function. Most typically you're going to use the exp variable. You could use an abs if you wanted to use an absolute value. This is typically the most common function that you will use to transform your axis variable, and this will back exponentiate your log dv, so we'll bring back the concentration on the log scale, on the linear scale, sorry. The other thing that you can control on a particular axis is the use of a linear or log scale axis. So we are actually doing kind of a full circle with this particular profile. We're still using the log dv as our y-axis variable. We're applying an exponent function, the exp function, and we are also setting the logarithmic scale field to true. So this field controls the display of the axis on the log scale, showing the logs and some minor tick marks on the intermediate values. So all these options are available on the x and y axis. I will now show how you can add some reference lines on top of the data. So in this case I went a little bit overboard. We're showing the log dv data as a scatter plot versus the time since first dose, and you can see all those red lines that are supposedly reference lines. We've got some horizontal lines, vertical line, and slanted line. The way you can add those lines is by going to the line panel, and I'm going to skip the smooth lines. We're going to show that in the last tutorial on scatter and line plot. And we'll talk about the rest of the panel. You can add coordinates for your horizontal line, and you can include as many lines as you want. The values must be separated by comma. So in my case I had 0, 2, and 4. So that corresponds to these 3 lines. And I used a single vertical line at 0, so that would be this line. And so you can display as many horizontal and vertical lines as you want. The slanted line, you can only use a single slanted line, and you must provide an intercept and a slope. So in my case I use a unity line with an intercept of 0, so this intercept of 0 and a slope of 1. The axis being non-squared or non-Cartesian. This line is showing a little bit pretty steep slope, an apparent steep slope. Finally, before we conclude this presentation, I just want to talk about the ability, the functionality to add custom titles and footnotes. For that, you need to go to the Advanced Settings panel, and the custom title field is at the bottom, and just above the custom footnote you can type any text that you want, and both in the titles and the footnote. So in our case, study 1 dose 10, that reflects the data subset, and a little bit of craziness in the footnote. So this concludes our first video on scatter and line plot. Thank you.